looking at equations of parallel lines. Now, having been told that to know whether two or more lines are parallel, you need to compare their gradients. If their gradients are the same, it means they are parallel. But you must also know that parallel lines have equations. So, what is the equation of a parallel line? It is y minus y1 equals to m into x minus x1. Now, someone may now ask, how do I obtain the equation of a parallel line? Now, I'll show you. Now, most of the time, you come across problems like this. Find the equation of a straight line that passes through minus 1, 3 and parallel to y minus 2x plus 1 equals to 0. Now, the straight line passes through this point and is parallel to a straight line whose equation is given. Now, when you look at the equation of a straight line, which is y minus y1 equals to m into x minus x1. Now, you realize that the only provisions that are made for here is just x1, y1. This other y and x are the variables in the equation. And m stands for gradient. Now, you'll now be wondering, where do you get all those things from? Now, minus 1, 3 is your x1, y1. Now, look at the other, the equation of the other line that's given to you, y minus 2x plus 1 equals to 0. What you need to do here is to rewrite this equation in the gradient intercept form so that you can obtain the gradient that you need to find the equation of that parallel line. So what you do is to say y will be equal to 2x minus 1. And therefore, your n will be equal to 2. Your n will be equal to 2. That is the gradient of that straight line will be equal to 2. When you rewrite this in the gradient intercept form, which you already know, isn't it? Now, having done that, then you go ahead to substitute those values into your equation. You have y minus, what's your y1? 3 equals to m, which is 2, into what? X minus x1, which is minus 1. Now, when you appropriate what is inside that bracket, you have minus multiplied by minus gives you plus. That will be x plus 1. Then you open that bracket. You have y minus 3 will be equal to 2x. 2 by 1 gives you 2. Then you move everything here to this place, just like the way you write your normal equation of a straight line. When you move everything over here, all the signs will change. So you have y minus, this comes out and become minus 2x minus 3. This also comes out and become minus 2 equals to 0. Then you have y minus 2x minus 5 equals to 0. That is the equation of that parallel line. So when they say, when the line passes through a point and is parallel to another straight line, you should find the equation. You get the coordinate of the first one given and also rewrite the equation of the other line if it is not already written in gradient intercept form. Now, we can also take a look at another example. For instance, you may have obtained the equation of a line passing through 2, 4 and parallel to y equals to x plus 5. Now, if you look at this question critically, you realize that the other equation of the other line is already written in gradient intercept form. So all you need to do is to just obtain your gradient from there. Now, what you do is your coordinate, which is x1, y1. Then from here, you realize that the gradient of this other line is just 1. Now, having obtained that and knowing how to find the equation of a parallel line, which is y minus y1 equals to m into x minus x1. And then you go ahead to say y minus y1 is 4 equals to m, which is 1 into x minus x1, which is 2. And when you open that bracket, you have y minus 4 equals to x, 1 by 2 gives you 2. So when you move everything from here to this place, you have y minus x minus 4 plus 2 equals 0. So at the end of the day, you have y minus x minus 4 plus 2 gives you minus 2 equals to 0. That is the equation of that parallel line. Then, having been done with that, we now quickly move to equation of perpendicular line. All right, let's look at the second example on equations of perpendicular lines. Now, when you come across stuff like this, obtain the equation of a straight line that passes through 4, 1 and perpendicular to y equals to minus 5x plus 2 and perpendicular to minus 5x plus 2. Look at that. That equation is already written in gradient intercept form. So it's just easy to pick out the gradient. Now let's look at the coordinate 4, 1. That is x1, y1. And from this equation, y equals to minus 5x plus 2, your gradient is simply minus 5. Isn't it? Your gradient is simply minus 5. And the equation of perpendicular line is y minus y1 equals to minus 1 over m into x minus x1. And then you begin to substitute the values in the equation. So y minus 1 equals to minus 1 over minus 5. Isn't it? Right? Into x minus 4, x1. So, what do? Y minus 1, minus times minus plus. So, it becomes plus 1 over 5. Right? Into x minus 4. Then, you open the bracket. Y minus 1 will be equal to 1 over 5x minus 4 all over 5. 1 over 5 multiplied by minus 4 gives you minus 4 all over 5. Then, you move everything here to this place. And while you are doing that, all the signs will change. So you have y minus 1 over 5x minus 1 plus 4 all over 5 equals to 0. And then what do? You solve minus 1 plus 4 all over 5. Now minus 1 plus 4 all over 5. Minus 1 means minus 1 over 1. The LCM of 1 and 5 is 5. 1 goes here, 5. By minus 1, minus 5. Plus 5 goes here, 1. By 4, 4. Minus 5 plus 4 gives you minus 1. So at the end of the day, you have y minus 1 over 5x minus 1 all over 5 equals to 0. And that is the equation of the perpendicular line.